Hello everybody and welcome back to another video. In this video, I have a list of 10 derivatives increasing in difficulty given to me by ChatGPT, and today I will be going through them all and solving them. So this list was just generated, so I have not looked at any of these beforehand, so let's get started. So for the first function, we are given f of x is just equal to x cubed. Now we are looking for f prime of x. So this is an incredibly easy function to do. However, I will be using the limit definition for this one to add a little twist to make it a lot harder. So we will be using the limit as h approaches 0 of f of x plus h minus f of x over h. So we will be plugging this into our function right here. So this becomes the limit as h approaches 0 of x plus h cubed minus x cubed divided by h. So when we multiply this all out, we have x plus h times x plus h times x plus h. X plus h times x plus h, that gives us x squared plus 2xh plus h squared. And now we have to multiply that by x plus h. And this gives us x cubed plus hx squared plus 2x squared h plus, 2xh squared plus xh squared plus h cubed. So now we have that this minus x cubed divided by h, and the limit as the h approaches 0 is equal to our derivative. Now these cancel since it's plus or minus, and now we can pull an h out of all these terms. So we can pull an h out, and we get h times x squared plus 2x squared plus 2xh, 2xh plus xh plus h squared divided by h. We could cancel these, and it's the limit as h approaches 0. So since we cancel these, we could just erase them. And now, as you can see, every term besides these two has an h in it. So as h approaches 0, these terms just go away, and we get x squared plus 2x squared, and that just gives us 3x squared, which would have been much easier to do with our general power rule. However, this is a very simple one, so I wanted to at least add a little bit of a twist. Okay, so the first one is complete. So we have one done. Now let's look at our second function. First off, let me erase. I will try to use a lot less writing for the rest of the other ones, so that way we will have more space to do multiple problems per erase, because this is kind of a pain to do. Okay, there we go. So for our second derivative, now we have the derivative of e to the x. Now this one I will not be doing the long version of. The derivative of e to the x is just e to the x. E to the x, when differentiated, is just going to be itself. So number 2 is completed. Now number 3, we get a somewhat challenging integral or derivative right here. So number 3 is, so this is 2, the derivative of ln of x squared plus 1. So we need to use the chain rule for this. So we have ln x on the outside, x squared plus 1 on the inside. So we need to do 1 divided by x squared plus 1, since the derivative of ln of a value u is just 1 divided by u times du over dx. So we have to differentiate this inside with respect to x, and we just get 2x. So number 3, our dy over dx is equal to 2x divided by x squared plus 1. So number 3 has been completed. Now let's take a look at number 4. So for number 4, we have the derivative of sine squared x. So d over dx of sine squared x. And let's say that that is equal to dy over dx. So this is number 4. So this is once again just a chain rule where we have sine of x on the inside and u squared on the outside. So this is just 2 times our inside function, since that's the derivative of a function squared, times the derivative of the inside with respect to x, which is just cosine of x. So this is our function. So this is our dy by dx. 2 sine x cosine x. So now we can do number 5. Also, you could simplify this with sine 2x. So this just becomes, what would that just be, sine 2x? Yeah. So now we can do number 5, which is x squared times e to the x. So we have f of x is equal to x squared times e to the x. Now f prime of x is going to be equal to, which is our derivative with respect to x. So we have to differentiate to x squared. So we get 2x times e to the x. Now we have to add x squared times the derivative of e to the x, which if you remember that is just e to the x. So this is our number 5. So we have 4. Oh wait, no, this is our number, yeah, this is our number 5. So we have 4 and 5 done. We are now halfway done. So halfway done. Now let's look at number 6. Number 6, we have f of x is equal to the arctangent of the square root of x. So the derivative of the arctangent I'm going to derive over here. Since I don't know if you guys just want me to plug and chug this whole time, as that would make the video quite boring. So let's just do our derivative for arctangent over here. So first off, we have y is equal to, so we have f of x, which we will let equal y is equal to arctan of the, let's say our function u, or let's say this is just x for now. We'll just find the derivative of arctan x and then do it from there. So arctan x, now we need to take the tangent of both sides. So tangent of y. So we have tangent of y is equal to x. Now we differentiate both sides with respect to x. The derivative of tangent x is just, or the derivative of tangent of y is just going to be secant squared y times dy over dx by our chain rule, where y is a function of x, so we have to pull it out. And that is equal to the derivative of x with respect to x, which is just 1. So now we can divide by secant squared, which is just the same as multiplying by cosine squared of y. So that goes away. Now we can just get rid of this 1. And if you remember, y was equal to the arctangent of x. So we can now make a triangle right here where we have a theta, where theta is equal to the arctan of x sorry, this is y is equal, or y is equal to arctan of x. Now we have dy by dx is equal to the cosine square of arctan of x. Now we are solving for the cosine squared of the arctangent of x. So we have theta is equal to arctan x, which means that the tangent, which is the opposite side over the adjacent side, is equal to x over 1. So the adjacent side is 1, opposite side is x. It means that this side is x squared plus 1. And since our cosine of x is equal to adjacent over, adjacent over hypotenuse, that means our cosine of x is equal to 1 over the square root of x squared plus 1. But we are looking for the cosine squared of x, so if we square this, then we get cosine of arctan x is equal to 1 divided by x squared plus 1, and that is our derivative of arctan x. So we have dy by dx, where y is equal to arctan of x is equal to 1 over x squared plus 1. Now we have a chain rule still. So we have f prime of x is equal to 1 divided by the square root of x squared, so these just cancel, plus 1, so this is x squared, and then we have to multiply that by the derivative of the square root of x, which is just 1/2 over 1/2 over radical x, so 1 over 2 radical x. So we can multiply here by 2 radical x, which gives us that this is 1 divided by 2x to the 3/2 plus the square root of x. This is our answer for our derivative. So number 6 is complete. And as you can see, that got a lot more difficult for that one. So I will need to erase to make more space for our next problem. So let's take a look and see what that next problem is in a second here. And our next problem is going to be the derivative of ln of x times sine of x. And this is just going to be a product rule once again. So the derivative of ln of x, I can solve this one for you guys actually. So we have y is equal to ln of u. Let's set y is just a function of u. So let's differentiate both sides with respect to u. Oh, we can just use x, it makes it a lot simpler. So then we get dy, oh wait, we get, sorry about that. Forgot to derive it for you. Okay, so we have e to the y is equal to the e to the ln of x, which is just saying e to the y is equal to x. Now if we differentiate with respect to x of both sides, we get e to the y, since the derivative of e to the y is just e to the y, and then we have to multiply it by the derivative of y with respect to x through our chain rule, and we get that is equal to 1. So then if we divide both sides by e to the y, we get dy over dx is equal to 1 divided by e to the y, but remember that y was just ln of x, so this is e to the ln of x, which is just equal to 1 divided by x. So our derivative of ln x is just 1 divided by x. So now we can use that here, so we differentiate the first term, so 1 over x times sine of x, so this 1 just becomes sine of x, plus the derivative of sine of x, which is just cosine x times our ln of x. So this is number 7 complete. Oh, now we have number 8 left to do, which is the derivative of x to the x. So we have y is equal to x to the x, and we are finding the derivative. So I'm going to take the natural log of both sides of this function. This gives us that ln of y is equal to x ln x, due to logarithm rules, where this x drops down and multiplies on the outside. Now we have to differentiate both sides with respect to x. So we get 1 divided by y, because our because our ln of y is that, times dy over dx through the chain rule, is equal to, we have to do a product rule on this, so we have ln x plus our 1. Since x ln x, if you take the derivative of ln x, that's just x over x. So now we have to multiply both sides by y, and we get dy over dx is equal to our y multiplied by that, but if you remember, y is equal to x to the x. So this is x to the x times the ln of x plus x to the x, and that is our derivative. So that is number 8 crossed off right there. Now let's do number 9. Number 9 is going to be the derivative of, so we have y is equal to x cubed divided by x squared plus 1. So for this one, we will just be differentiating with respect to y, so dy by dx is equal to the derivative of this with respect to x. So we need a quotient rule right here. So we have our f of x, so the derivative of that, so 3x squared times our bottom, which is just x squared, plus 1, minus the derivative of our bottom, which is just 2x times x cubed. So let's rewrite this as x to the 4th. divided by our bottom squared, so x squared plus 1 squared. So that is just x squared plus 1 times x squared plus 1, so it becomes x to the 4th plus 2x squared plus 1. So divided by x to the 4th plus 2x squared plus 1. So dy by dx is equal to this 3x squared multiplied, so we get 3x to the 4th plus 3x squared. And then this 3x to the 4th subtract from that one, so we get x to the 4th, since the 3 minus the 2, plus our 3x squared, divided by x to the 4th plus 2x squared plus 1. And that is our derivative. Okay, so one more left. Number 9 has been completed. Now for our final one, let's see what ChatGPT thinks is the most difficult derivative that it feels confident enough to give me. So this will be our final derivative. I won't erase, actually I'll just erase all this so we have as much space as ChatGPT thinks we might need. So I'm just going to give this all a big erase, and let's take a look. Not perfectly clean, but that doesn't matter. So our final function is y is equal to cosine of x raised to the x squared. So let's begin. So this, first off, when I look at this, I just see a chain rule. So this isn't that bad. However, that's incorrect. You have to do a logarithmic differentiation on this problem. So this gives us ln of y is equal to x squared times the ln of cosine of x. Now, if we differentiate both sides with respect to x, we get that this is just 1 over y dy over dx is equal to, now we need the x squared derivative, so we have 2x times our ln of cosine of x plus now our x squared times the derivative of the ln of cosine of x. So the derivative of the ln of cosine of x is just going to be 1 divided by cosine x times negative sine of x, which is just negative tangent of x. So plus x squared, and this plus becomes a minus when we multiply this by the negative tangent of x. And now we have to go ahead and multiply both sides by y, and we get dy over dx is equal to, remember our y was cosine x to the x squared, so this is cosine x to the x squared times 2x ln cosine x minus x squared tangent of x. And this is our final derivative for this problem. Number 10 has been checked off. So do you guys think this was all in a fair order? I do believe that this last one is very difficult. And I actually didn't realize at first that I had to do a logarithmic differentiation. That's why I said it halfway through almost. However, I hope you all enjoyed this video. Leave any questions, comments, concerns in the comments, and thank you for watching.